Hi everyone, my name is Avek, and from this lesson, we are going to start module 2. So, guys, if you remember in module 1, we have discussed the whole foundation of system design, like what exactly is system, how internet actually works, what exactly, is API, what are all the vocabulary that we need, to have any kind of system design conversation. So, all this foundation we have already discussed in module 1. And guys, before starting module 2, I want to bring back to some important thing that we discussed there because that will be the start of our module 2. So we made a very simple system. Like, what was the very simple and minimalistic system? We have one client, okay? We have one server, okay? Both client and server are communicating to each other. Like, client is sending a request, server is sending a response, and both of them are connected to each other because there is an internet, and internet is a provider by which they are able to communicate. We have already seen that. Now, in majority of the cases, like in most of the application, this simple system eventually works perfectly fine. Like if you are making an MVP or if you're making an app which is where you just started, you don't have much traffic. So in all these scenarios, the simple system eventually works very much fine. But guys, if you remember, we discussed there were three main problems by which the simple system starts breaking. And what were those three problems? Let's try to recall them. Problem number one, let's say you have a simple system, okay? Right now, your system is able to handle 500 requests per second. Like in 1 second, it can answer 500 requests. But on one day, instead of 5,000, your system got 5 lakh requests per second. So guys, this is a huge amount of request in a single second. And your system haven't seen this much of request before. So there is a huge chance that your system might get crashed. Like it won't be able to answer all these requests in a 1 second. So your system, might get crash. So when there is a huge amount of traffic, the simple system, like the simple architecture that we just developed right now, might start breaking. This was the problem number one. What was the problem number two? The problem number two was, let's say you only have one server right now, but the server is also a hardware. Okay. Now imagine if you have, power cut. If you have a power cut or something happened to your hardware because you only have one server. So if it gets down, your whole architecture or your whole application get down. No user can access your application because the server which is able to answer those requests is not available. So this was the problem number two. What was the problem number three? The problem number three was actually, let's say if your server is in US and the user in India is trying to access your server by making a request, then there is a huge chance this will take time. Why? Because the distance between US and India is very much high. So your request firstly needs to travel to USA, then it needs to process the request, then it needs to come back from US to India. Even if it is coming in the speed of light, it will take time to respond. So your user might feel, hey, there is a huge delay in getting a response. Your application is very slow. It just keep on loading. It's not giving me the correct answers. So these were all three problems that we discussed we have in simple system. Now in this module, we are going to discuss how exactly we are going to solve these three problems. So basically, to solve these three problems, we need to make our system scalable. What we need to do? We need to make our system scalable. And if you remember in the last module, the last lesson, the last word in vocabulary we discussed, scalability. What was scalability? Scalability is nothing but it is ability to handle growth. Growth means, of course, there is a huge amount of traffic is coming. All these, if any of the problem is coming, then your system should be able to handle it without any failure. So what was scalability? I'm giving a very simple definition of scalability. It is nothing but it is ability to handle growth, okay, without any failure. This was a simple definition of scalability. Now, in this lecture, we are going to discuss how we can make our system scalable. So guys, right now, if you see, we only have one server in place, okay? Now just imagine if you want to make our system scalable, there are two options, okay? There are eventually two options if you really want to make our system scalable in terms of server. What was option number one? Firstly, let's say your current server has some specification. Let's say it has 2 GB of RAM, it has some memory, it has some disk, it has some, let's say ROM or something like that. Like these are some minimal specification that your server has right now. So one way is that you can just make your hardware more bigger in terms of specification. Like instead of 2 GB of RAM, let's take 100 GB of RAM. Let's say your system is having 100 GB of storage. So instead of 100 GB of storage, you are now having 1 terabyte of storage. So eventually what we are doing, we are trying to upgrade our hardware by improving or by increasing the specification. Okay, we are just making our server more bigger. Are you getting it? So let's say eventually if instead of 5,000 requests, now if you're making your hardware more bigger, then it might be able to answer 5 lakh requests per second. So this is what this is actually the first way to scale your system. And what is another way? Another way is that let's say you have only one server right now with this specification. What you did, you haven't changed any specification. Okay, you just increase the number of computers. Like instead of 1, you are adding 3 or 4 computers with the same specification. So what is the advantage of this? Let's say if this server has some failure, then other servers can handle it. So there's a huge amount. So there are two ways by which you can scale your system. Number 1, either you increase the size of server. Number 2, either you add more server. And both of them have some name. So this we call, like when we increase the size of server, we call it as vertical scaling. Okay. And when we add more computers, then we call it as horizontal scaling. Are you getting it? And as a good engineer, it is very important to choose which one to adopt in your own system, because majority of the cases, even senior level engineer is not able to take this decision correctly. Like for our use case, what is the ideal way to go through? So in this lecture, firstly, we will discuss what exactly both of these scaling are, like what is vertical scaling, what is horizontal scaling in more detail. Okay, and then we also try to see how exactly we are going to choose vertical or horizontal in our own use cases. So guys, let's discuss about this vertical scaling in detail. Okay, so if you go to tech Twitter or if you go to LinkedIn, like many people will tell you, hey, let's do horizontal scaling, let's ignore vertical scaling. But you know what, this vertical scaling is actually very underrated. Okay, like in lot of real situation, vertical scaling is the most practical thing that anyone can do. Like, let me tell you what exactly are the pros of vertical scaling. Okay, so firstly, if you want to do a vertical scaling, there is no code change. And this is actually very important, because let's say if you have a small server earlier and you have some code written. Okay, now with that same code, if you just increase the size of your server, the same code can eventually run on this big machine as well. Like you don't even need to change a single line of code to run that on a bigger machine. So if you're not changing any line of code, that means there are no bugs, and it is very much easier. So this is actually the very first pro. What is another pro is that, let's say if you have multiple servers means you have multiple machines, and each machine you have to put logic. Sometimes what happens, this is a distribution system, like this is a class of distributed system, and distributed system is very harder to manage. Are you getting it? So this can have its own class of bugs. Like there are some bugs. Let's say if there are 2 machines and both of the machines are not agree to the same thing, then this is a huge clash. So with this vertical scaling, you are actually avoiding lot of bugs and lot of hard stuff. Are you getting it? Because you have just increased the size of server. Your code is same, everything is same. Another interesting pros is that operation to do in vertical scaling is very much simple. What exactly I mean by operation is that because you only have one server, so it is very much easy to debug any kind of bug, because you only have one place to look at. Like you don't have multiple machine to debug some log. You just have to go to one place, check everything there, and yeah, you are good to go. If you want to deploy something, you are just deploying this one server. You don't have to worry about multiple machine at the same time. So all these are the very interesting pros of vertical scaling, and in most of the real case scenarios, this is actually best way to scale. And if I tell you the one real world example is that, like a long time back, right now Stack Overflow no one use it, but Stack Overflow actually written in their article, like they are able to handle this much amount of traffic with this vertical scaling. Like they have made their server very big in terms of specification, and they are able to handle huge amount of traffic and something like that without any code changes. So this is actually interesting. Okay, you have to take care of this point, because vertical scaling is simple to do and it can make your life easier. Now, what are the cons of vertical scaling? Okay, like of course there are pros, but there are cons that why horizontal scaling actually exists. Firstly, the number one con is that because in this scenario also you only have one server. Even though it is very big, it doesn't matter, but you only have one server. Okay. Now let's say if this one server has some power cut. Again, the same problem. User is not able to access your, access your website, access your server. So this is actually interesting. Even you are increasing the size of server, power cut is a very, practical thing, and it can disrupt your whole operations. Okay. Another thing is that, like, what is the first con? Power cuts and something like that. Okay. Another thing is that, let's say, even though you are making your server as a big one, okay, but this also has constraint. Like, if you want to make your server big, how much big? Like, you can make it, let's say, 100 terabyte of thing, but still it has some limit. Like, you cannot infinitely make it bigger. There is a limit. Okay, so there is always a ceiling or a limit by which you can increase your server. Okay. Another thing is that as the specification of your server grows, the cost to rent that server increases. Okay. And it is very interesting. Let's say even if you double your server, sometime, let's say you were paying X amount of air, on doubling this thing, you are paying 3X amount of air. So as as the server size increases, the bill amount increases, but it increases sometime in an exponential way. So this is not good for, for if you're doing business, then this is, of course, you don't want. What is another thing is that, let's say if you want to upgrade, like if you want to do some deployment or you upgrade your system, then you have to make this server down for some time. So in that period, like when you are upgrading your server, in that period, users won't be able to access your platform. So this is also not good. So this is actually impacting your availability. Are you getting it? And availability, if you remember, we learned about this availability term in module 1, lesson 4. So I hope whoever is watching these lectures have already watched the previous one, because it is all interconnected to each other. Okay. All the words that I'm using we have already discussed. So guys, these are very important cons of vertical server. Okay. But of course, these are pros. If you're happy with the pros, like let's say if you have just developed something and at one day you got huge amount of traffic. So this is a very quickest way to scale your server without thinking any stuff. You're okay, without doing any hard stuff. So to solve these cons, that's why we have horizontal scaling. Okay. And you know what? Horizontal scaling is the one which is actually used by majority of the companies that you see online. Like if you see Google, if you see Amazon, if you see Uber, like all the big tech companies actually rely on horizontal scaling. Like if you take example of YouTube, okay, YouTube serves billions of videos per day. Like with vertical scaling, it is not even possible to do such kind of operations. Are you getting it? So horizontal scaling is very much necessary for these kind of players. So horizontal scaling we have already discussed. When you are adding more computers in your server as a server, then of course that is called as horizontal scaling. Okay. Now, what are the advantages of this horizontal scaling? Like why people use horizontal scaling? Of course, the first one is that this actually provide you unlimited scale. Are you getting it? Unlimited scale. Like if you see in vertical scaling, there was a limit. Like at certain point of increasing the specification, you cannot go beyond that point. But let's say in horizontal scaling, unlimited scale. If you want more scalability, add more. It is as simple as add more computer. Let's say right now you are working in 10 computers. If you add 100 computers, it will work more. If you add 1,000 computer, it will work more. So it is just increasing the number of computer, you are increasing the scale. So there is an unlimited scale. Okay. What is another advantage? Of course, the very important advantage is that even if there is a power cut, your system will not get disrupted. Let's say one computer dies suddenly, but your other computer can still handle those users, and your users won't face any kind of disruption. And this is actually very important in terms of availability. Okay. And what is another pros? The third problem that we discussed, that is, let's say if your server is in US, someone in India accessing your server, the response time get increased, but this thing can actually save it. Now, because you have multiple computer, so you can put multiple server at multiple location. Let's say one server is in US, one server is in India, one server is in Africa. So you have put server in different locations. So whoever user making request to your platform, whatever server is nearer to the user, the request will go there and user will get a response. So in this kind of scenario, they will have a faster response time. So these are actually three very important pros due to which horizontal scaling is very much trending. Like all the big tech companies are actually using it. Okay. Now, what are the cons of this horizontal scaling? The very first con is that it is actually super hard to set up. Like guys, like why I was saying vertical scaling, because let's say if you're a beginner, if you just started a company and suddenly huge amount of traffic is coming out, you just need to increase the size of server. Okay, your code is there, everything is there. You don't need to do any kind of change. But if you want to do a horizontal scaling, you actually need to change everything in your code base. Like you need, because now you have multiple computers to operate, and to multiple computers to operate, whatever algorithm that you wrote, whatever code you have to wrote, you had wrote, you need to modify them based on different computers. Are you getting it? So the very first con is that it is actually super hard to, set up. Another con is that now because you have multiple computers, your debugging might be very hard. Why I'm saying that? Because let's say if you have some bug, then you have to monitor 3 computers. Let's say if you have 1,000 computers, if you have some bug, you have to monitor maybe 1,000 computers. So because of more computers, you need to do more resources, more people need to monitor these kind of computers. So it is very hard to debug when such kind of scenario happen. Okay. And another thing is that, which is actually very interesting, and we will discuss this in detail. Okay. And that is state is hard to maintain. Now you must be asking what exactly is state. So let's discuss state in detail in this lecture only. Then you will get to know what exactly I meant by this point. Now, before starting the discussion on the state, I write one line here that is, it is super hard to set up or configure. But you know what? This point is also depend on this third point, state. Now let's try to understand, okay. What I mean by state is that there are two important terms, that is stateful or stateless. Okay. And horizontal scaling is easy or difficult to set up is depend on these two things. Whether your system is stateless or your system is stateful. Let's try to understand, okay. What exactly is stateful? So stateful means your server remembers everything between a request. Let's say you make one request, okay? You made another request. So whatever is happening in the first request, in second request, your server might be aware of that, okay? And what is stateless? Stateless means your server forget between request. That means each request is actually don't depend on anything. Like for example, if you made a request, you ask something, you made another request, in that request it will treat as a completely fresh one. Like it is not remembering anything about you. So stateful means server remember between requests. Stateless means server forgets between requests. Now I know this might sound simple and you might be saying, hey, I'm not even getting what exactly you're saying. Let's please try to explain me with some example. Okay, so let's take an analogy. Okay, so let's say you have your favorite coffee shop near a town. Okay, let's say you go to Starbucks daily. Okay, now since you are going to the Starbucks every day, they actually know you. Like this Starbucks place actually know you. They know your name. They know you what kind of coffee you like. Let's say you like cold coffee. You are ordering cold coffee every day. So whenever you're going to that shop, they will asking you, hey, okay, we are making the cold coffee for you because this is what you usually order. Okay, so they knows your preferences. They knows everything. Now what happens? Let's say one day the Starbucks shop get closed. Now there is another Starbucks shop nearby your locality. Now you go there. Now just tell me, when you are going there, you need to do everything from scratch. Like this Starbucks doesn't even know what exactly you used to order in another cafe or another place. Okay, so this is actually a stateful thing. Now tell me, is this a good experience for you? Because you are just going to a Starbucks cafe. It's just you are changing the branch, but they don't even know what exactly you order. So this is actually a stateful example where the memory about you, like what your preferences, what's your name, lives only in one place, one cafe. That's it. Other Starbucks chains might not remember you. Okay, so this is actually stateful. Now let's take an example of stateless. Okay, let's take an example of stateless. So guys, let's say you are going to an ATM. Okay, you went to an ATM at some place. Okay, you withdraw some money. You got the money. Now it's all good. Now you go to some another city, and in that city you went to another ATM. Now in that ATM, you can just put your details, and it will show you everything up to date, like what is your current balance, what is everything, what are your last transaction, and you can eventually withdraw your money there as well. So ATM is an example of stateless. Like different ATM is not even remembering anything about you. Why? Because every time you are inserting a card and your information is somewhere else. This particular ATM is not storing anything about you. They are just getting the information when you are inserting the card. Are you getting it? So this ATM is actually a stateless example. And the coffee shop is actually stateful example where this particular shop knows exactly about you, but you are changing a location. Now this new location cafe might not remember anything about you. Similar to this, a server can remember you and can forget you. It all depends on stateful or stateless. So let me show you exactly in terms of server. Okay, let's say you have one website, like you went to amazon.com. Okay, Amazon had, let's say, 2 servers, server 1, server 2. Okay, let's say when you went to Amazon, your request goes to server 1. Okay, now this server one actually remembers everything about you. Okay, hey, in your cart, you added actually one product. Okay, it's good. Now you added another product. Now you have two product in your cart. So this server knows exactly about you. Now what happens? Another day you open Amazon, you log in with your account, but for some reason this server is not available. Your request goes to another server. But this server is not even aware what exactly you added yesterday because this information is actually where? This information is actually in server one. So this is a scenario. In this case, like this is a scenario of stateful. When your server tried to remember things, it is not scalable. Now tell me, is this a scalable solution? Stateful is not a scalable solution at all. Are you getting it? And this is a reason. Now, let's say if Amazon works on stateless thing, then how exactly it will operate? Okay. So instead of remembering anything, right now your memory is inside a server. But instead of remembering anything, what they did, they tried to make a shared, let's say DB. Whenever you are going there, one server says, okay, you added one product. So instead of writing its own memory, it is writing in a shared database. Like it's writing, okay, he added one product. Now he added another product. Okay. So one day you go there, it instead of storing here in its own memory, it stored in this shared database. Now what happened? Next day you went to server 2. Even though server 1 is crashed, so what will this server 2 will do? This server 2 will go to the shared database and it can eventually see whatever you actually added. So that's the example of stateless. In stateless, server is not storing anything about you. They are actually accessing everything about from a shared place. Now, stateless is very much easier to scale. Let's say if you want to add multiple server, you can easily add it. Why? Because still you have a shared place to store everything. But in stateful, where the memory is inside one server, it is difficult to scale because the more you are adding servers, the more difficult. And let's say one server dies, and of course the same problem happens. This server is not even information of this user. Are you getting it? Now, next important concept is there, like when exactly to choose like horizontal scaling or vertical scaling, because this was the very first question that we just discussed. Like if you are scaling, then what should the preference? Like, should you go to vertical scaling or should you go to horizontal scaling? See, to be honest with you, if you have an app, if you have a simple system, okay, the first thing that you always should do is actually go with vertical scaling. Why? Because vertical scaling is super easy to do. You are just increasing the size of server and it is able to fulfill more requests at the same time. Okay. Now let's say if vertical scaling is not enough, vertical scaling is also breaking or having some problem, then go to horizontal scaling. But now remember one thing. Since in vertical scaling, you only have one server, there is a high chance everything is getting saved inside the memory of this server. So if if you are thinking, hey, okay, we can just add new server. But in this case as well, you are adding a new memory here. Eventually, this server has its memory, this server has its own memory. Now, when you go with horizontal scaling, you can add more computer, but you need to plan one more thing, and that is you need to plan for stateless. Like you need to make sure these servers should not have its own memory. They have some shared DB and all the things should be redirected to that. So firstly, if you want to scale, go to vertical scaling. If vertical is not happening correctly, then go to horizontal scaling. But with horizontal scaling, also try to plan for stateless. I hope you got the point. So this is a whole crux of this lecture. Like we discussed what exactly is vertical scaling, what exactly is horizontal scaling, when to do when, what are the pros of this, what are the cons of this, what exactly is stateful and stateless. And stateful and stateless is actually a very important concept in this whole scalability kind of concept. I hope you got everything. So I'll see you in the next lecture. Super excited.